we're now going to do a few examples of reversible reactions, and we're going to study the Le-Chatelier principle and its application. Now, first, let's say this reaction is at equilibrium. It has reached equilibrium, and our question is, the first question is that what's going to happen if you decrease temperature. So if we decrease temperature, and we're going to apply what we learned just in the previous video lectures. Now the first thing, if we decrease temperature, the Le-Chatelier principle states that the equilibrium would try to increase temperature. So the equilibrium would try to increase temperature, and whenever it tries to increase temperature, it's the exothermic reaction which would be favored. So our exothermic reaction in this case would be favored. Is favored. So our exothermic reaction is favored. Let's underline that. And let's see which one of the reactions is exothermic. Now the enthalpy change of this reaction is positive, which means that the forward reaction is endothermic, or vice versa, which also means that the backward reaction is going to be the opposite. It's going to be exothermic. So if I increase temperature, the exothermic reaction speeds up, which in our case is the backward reaction. So we're going to write that the backward reaction speeds up compared to the forward reaction. It doesn't mean that it's actually speeding up. It just means that the backward reaction is faster compared to the forward reaction. And the our equilibrium would let me clear that. So our equilibrium would shift to the left hand side. To the left hand side, or it would favor the left hand side, or we can say it would favor the reactant side. So if we decrease temperature, equilibrium would try to increase temperature. If it tries to increase temperature, the exothermic reaction would speed up. The exothermic reaction in this case is the backward reaction, because the enthalpy change is positive, which means the forward reaction is positive, endothermic, and the backward reaction would then be negative, exothermic. So the backward reaction is releasing energy, it's increasing temperature. So the exothermic reaction, which is the backward reaction, let me underline that again, the backward reaction would speed up and equilibrium would shift to the left hand side. More NOCl would be produced. In this example, we have PCl5, which is decomposing to form PCl3, and it's producing Cl2. And when the reverse reaction is also happening, these two are combining together and they're forming PCl5 back again. And the reaction is endothermic, which means that the forward reaction is endothermic, whereas the backward reaction is exothermic. So let's assume that this reaction has reached equilibrium. The rate of forward reaction and the rate of backward reaction are equal. And let's change the conditions now. And in this case, we are going to change the conditions that we're going to change is we're going to try, let's say we increase pressure. If I increase pressure, what would the Le-Chatelier principle state? And where would the equilibrium shift? Which side would be favored? So if I increase pressure, the equilibrium is going to do the opposite. It's going to counter that. It's going to try, equilibrium tries to decrease pressure. And your pressure would be decreased if there are lesser particles, there would be fewer collisions. So So the lesser volume side would be favored. If you increase pressure, what you're basically doing is, if you increase pressure, you're compressing it. You're compressing your system. It's like a piston. It's like compressing something. So if you increase pressure, you're compressing it. There would be lesser volume. So equilibrium tries to decrease pressure, or we can say that since there is lesser volume, the side which occupies a lesser volume would be favored. So the lesser volume side would be volume side is favored. Now, which side is the lesser volume side? You have you can check the lesser volume side. Let me correct this. So if you have the lesser volume side and you're finding the lesser volume side, so you can check the lesser volume side by looking at two things. One is by looking at the states, and the states are exactly the same. They're all gaseous, so the states will not be of much help. So you can look at the number of moles. So you can check out the side which has the lesser moles. Lesser moles means there are fewer particles. Fewer particles means that they would occupy a smaller volume. So there are 2 moles on this side. So this side has 2 moles, whereas this side has just 1 mole. So this side has 1 mole and the other side has a total of 2 moles. So the lesser volume would be occupied by PCl5. So PCl5, the production of PCl5 would be favored. The forward reaction would be more difficult as you don't have a lot of volume. You're compressing the whole system. Whereas the backward reaction would be easier to accomplish because you now have lesser volume. So the lesser volume side would be favored. So lesser volume side is favored, which means that the backward reaction it speeds up. Now if the backward reaction is speeding up, which means that equilibrium shifts to the left hand side. Shifts and favors the left hand side, which is our reactant side.